So here we have a copper wire of radius r, carries a constant current I. You have to find average drift velocity of the electrons if the density rho of the copper is given. So we basically have to find drift velocity. Now, since it says a wire, so we assume that it's a cylindrical shape of the wire, and now we want to find a drift velocity. First of all, we know that drift velocity, the drift velocity is given in the formula. This is the first formula that we're going to use, nqa. Then we know that area is given, so since if you imagine that it's a cylindrical shape, then nq area will be pi r squared. Okay, now we can see that we don't have here the density, so somehow we have to bring that density here. So what we should do? First of all, we know that we have n is equal the m divided by capital M is equal n divided by na, correct? So don't be confused. This n is not that n, okay? This is not that n, okay? Because this small n, that small n, is basically number of charges E per unit volume. Okay, so this is different n. Then then that means if that's the case, then this n is equal to what? This n is equal number of electrons divided by the volume, okay? Or number of charges divided by per unit volume. Now, then how can we find this number of charges? Then we have to use this formula, where in this case n is equal mass divided Avogadro's number divided by molar mass. Okay, if that's the case, then is equal to the m n a divided by molar mass of the copper and volume. Okay, and we can see here that m divided by v can give you rho, right? So that means n is equal rho n a divided by molar mass of the copper. Okay, so I think we got everything. Now let's plug it here. So current n is equal rho Avogadro's number, molar mass goes up of the copper, then here pi r squared, and then we have a q. Now the q here is equal the magnitude of the single charge, which is 1.6 times 10 to the power of minus 19 coulomb. Okay, so that's it. I think if you plug the numbers, you should get the answer.